I built an RC car that lets me see anywhere live. Here's how I did it. The components needed for this project are a Pi 5, which is the brains of the project, a 9-volt battery to power the motor driver, an L298N motor driver for driving the motors, 4 TTT gear motors with wheels, a Raspberry Pi camera for live feed, an SG90 servo for the servo camera mount. The 3D print needed for this project are a car chassis base plate, 4 motor attachments, the servo camera mount. Once you have printed all the pieces, the first thing you're going to be assembling is the motor assembly. So first you need to take the motor attachment and connect it to one of the motors, which I'm doing so right here. Once you have done that, it should look like this, and now I'm going to screw it in together. Now that it's screwed in, it should look like this. So now I'm going to repeat it for the next one. So I'm going to take the next one and do the same thing. So I'm taking another motor and connecting it. Now I'm screwing it together. Once you have done that, another motor attachment is connected. So I'm going to repeat for the next two. Now that everything is assembled, it should look like this. So you should have 2 left and 2 right, and I'm going to show you how to connect it to the chassis of the RC car later on. To build the tilting servo mechanism, the first thing you need is the base, which is this piece right here. Then the next piece you need is this servo connector that goes on to the base plate like this. Once you do that, the next thing you need is one of the servos, which is given into your kit. And then once you do that, you need to have this printed piece, which is the body, and that connects to the base plate right here. And from there, you need to screw it from the bottom. Once you have screwed the bottom and the body of the tilting servo mechanism, the next thing you need is the header with a servo. The servo connects like this, and then you need to screw in the servo into the header. The next thing you need to do is take one of the servo connectors like this and put a screw through the 4th hole, and then you need to put it into the body of it like this and screw the screw into it, and it should pierce through the body of the servo tilting mechanism. Once you do that, the one screw that you have left, which is for the servo, needs to go into the mounting part of the servo so that the header and also the body gets connected to each other. Now you need to screw those two together, just like this. Once you're done, you should take one last screw and then you should put it through this hole, which is right here, that goes through the head and the body so that the head and body can be connected to one another. Now the tilting servo mechanism should be assembled. So to assemble the car, the first thing we need to do is add 8 screws, 2 here, 2 here, 2 here, 2 here. This is what allows the motors to connect to the chassis. So now I'm going to show you how to connect the motors to the chassis. So you have these negative and positive lead. Those need to be facing inside. So it goes through the holes right here and right here. Once you have connected all the motors to the chassis, you need to screw them down. Once you have screwed all the 4 motors, now we need to route all the cables. So what I'm going to do is show you how to do that. So we have to take the motor leads and put it through the holes like this. Once you have routed all the cables like this, it should look like this where two red, two black on each end through the holes. The next thing we need to attach is the camera servo mount, which goes right here in these four holes. So I'm going to screw them down now. Once you have connected the servo mounting system, it should look like this. So the next thing we need to take is the Raspberry Pi 5 and insert it into the holes like this. So what happens now is once you add the Pi, the USB port should be facing towards your side. Now that the Pi has been attached, next thing we need to attach is the motor driver. This LN29 motor driver should be attached here. Now that all the parts are connected to the chassis, in next part I'm going to show you the schematic so that you can connect all the motor driver to the Pi, then the tilting servo mechanism to the Pi, and also the motors to its motor driver, and also the 9-volt battery. To build out the schematic of this project, the first thing we need is the 4 TTT gear motors and connecting it to the motor driver. Then next we need to connect the pins here to the Raspberry Pi. So EN-A goes to GPIO 22, IN-1 goes to GPIO 17, IN-2 goes to GPIO 27, then IN-3 goes to GPIO 23, IN-4 goes to GPIO 24, EN-B goes to GPIO 25, and then we need the 9-volt battery. The 9-volt battery goes into the positive lead goes into 12 volt terminal, then the negative goes into the GND, and then you need to take one lead, which is the GND, and take it and connect it to the Raspberry Pi's GND pin, which I haven't shown here, but you should do that. And then next, you need to take two servos. The tilt servo needs to connect to the Raspberry Pi as well as the pan servo. So the pan servo connects to the Raspberry Pi as the GND pin goes to GND, VCC goes to 5 volts, and then the control pin goes to GPIO 26. Then for the tilt, the same thing, except the control pin goes GPIO 16. So that is it for the schematic. Now in the to program the Raspberry Pi RC card, the first thing we need to do is import some libraries like the GPIO0 library, time library, Pi camera library, lib camera library, flask, threading, CV2, and also Pygame. So what these libraries do is allow us to control the motors and the servos, as well as see live feed from the Pi camera, as well as control the car using the Nintendo Switch controller. So the next thing we need to do is have a motor setup. So we have the left and right motors. Then we need to control the servo motors, which I've set up here also. Then next we need to do is the camera setup, which is right here. Then we need is the Flask Live, which is basically the web browser or the web stream that you can see the live feed into. Then finally, the last set of code is tuning. Tuning, what it does is make sure when the controller moves forward, the car moves forward also, and if it goes backwards, it goes backwards. So that is the code for this project. After building and coding the Pi car, you can drive it with a Nintendo Switch controller and watch live video feed right in the web browser. But the coolest part, you didn't even need to be in the same room because the control interface runs over the network. This thing can be driven from literally anywhere, down the hall, across the house. That is it. A fully working Raspberry Pi RC card with camera tilt, live video feed, and a Nintendo Switch controller support. Awesome board, and it's only getting better from here. Next up, Alexa voice control, so you can literally talk to this thing and watch it move. If you enjoyed this, smash the like button, subscribe so you don't miss part 2, and drop a comment with your thoughts or questions below. Thanks for watching. See you in the next one.